Hello everyone, and welcome to this talk on threat modeling. My name is Aedan Lawrence. I am a security engineer for SecureFlag. I've been there roughly 3 years now. As you can tell, I'm not from around here. I'm originally from the UK, currently living in Germany. So this threat modeling has been designed to provide a lightweight approach for developers. It's been designed, therefore, with developers in mind and in order to reduce the reliance on security experts. Thank you very much. It's a good start, I know. So let's talk a bit about what threat modeling is, when we should do it, and why threat modeling really matters. So threat modeling is an activity to identify potential security threats and use the appropriate security controls to mitigate them. Essentially, what we are trying to do is catch vulnerabilities early before they ever become a real problem. And obviously, since we are trying to anticipate potential vulnerabilities, threat modeling should ideally be performed in the design phase of software when it's still easy to make changes and it's still cheap to make changes. So we should also obviously continue to revisit the threat model as we make changes to the system, just to make sure that the threat model has the most relevant and up-to-date threats. From those few points, you can see why threat modeling can be an important activity when it's executed at the right time. It helps us to identify issues early on in the software development lifecycle when it's still possible to intervene. And in this way, we can also manage our resources accordingly. If we identify the issues too late in the game, it will be more expensive, more time-consuming, and possibly affect the go-to-market of our application. And finally, threat modeling helps us to meet regulatory compliance, something that's becoming more and more important. So let's start by taking a look at the traditional threat modeling process. Obviously, this is an OWASP event. Hopefully, lots of you will already know what threat modeling is. But essentially, we start by defining the scope. What is it that we are going to model? In traditional threat modeling, this will usually be the entire application or system, so quite a large scope. And then for that scope, we start by drawing the diagram. We map all the individual components, the way in which data flows, and at this stage, we can also identify the trust boundaries. Essentially, trust boundaries are the point at which the level of trust of the data changes. So maybe that's from a user into our system, or maybe it's from our system to a third-party service. At this point, obviously, an entire application or system, it's quite a high-level overview. We would need quite senior members of staff to join us. So we'd need system architects, application development leads, quite senior, quite busy people that really have that key oversight of the application. Next, we can move on to identifying threats. This could follow a structured technique, such as stride or pasta. And at this stage, we would also be joined by people from the security team to help in identifying those potential threats. And once we've identified those threats, we can evaluate and check maybe they're already mitigated, maybe we need to make some changes, and we can assign a risk rating at this stage to each of the threats and prioritize them for risk remediation. And finally, in terms of risk remediation, obviously we use those countermeasures, we map them to the diagram, and we have a way of dealing with the threat. Finally, we document and review. We will add all the risks, all the threats, all the controls, and all mitigation strategies to a document, keep this document, and then we will continuously update the document as the model changes and as the system evolves. So let's understand the problems with this and why it can be difficult to scale threat modeling in this way in the software development lifecycle. So obviously, we are creating a, sorry, it's a bit weird having the sync out of place. So obviously, we are involving that very large number of senior people that we need to model the entire application or system. As I've said, these people are usually very busy. And to model the entire application or system, we will usually need a meeting that lasts for several hours. This is OK the first time we do the threat modeling. It will be easy to organize. But to review the threat model, to update the threat model as we need to make changes, it becomes really hard organizing these meetings over and over again with these senior people. And the other problem we have due to this is the scope of the model. We're creating the entire application or system as a model, and this will usually result in a very broad scope with lots of threats, lots of controls, but actually most of it won't be that actionable. the results won't be that usable, and therefore the value from doing all this threat modeling can be quite limited. The other problem we have with scaling is the need for security experts. Attackers, application development leads, system architects, they often lack the mindset of an attacker, and therefore to get good exploits for the attack, we would need someone from the security team to join us, and that person will also need to have knowledge of threat modeling. This person is quite scarce. There's not loads of security guys that know how to do threat modeling, and they will also be very busy people. So this really creates two bottlenecks in the system for threat modeling that can really limit its scalability in large or fast-paced organizations. So overall, it's, as I've mentioned, very resource-intensive activity that provides very limited values. The other problem we have with traditional threat modeling is it's quite often done at the end when the application has already been built. This means that if we do get results, we'll get hundreds of results, hundreds of vulnerabilities, and realistically, the controls that we have for those vulnerabilities, we won't have the time to implement them without affecting the go-to-market strategy. So this is where at SecureFlag, we have developed a developer-driven, tool-agnostic, rapid threat modeling methodology. So the target audience of this methodology is individual developers or small developer teams, essentially creating something that's much more manageable for them. And because of that, the scope of this methodology is individual functionalities and critical components. Think of like authorization, authentication, money movement. Sort of those pieces of functionality are really the scope, much, much smaller and therefore much easier to be managed. And finally, in order to reduce reliance on security experts, we've created a collection of lists for a given context. These lists contain 20 threats and 20 corresponding controls for each of those threats. And we have called these lists risk templates. And essentially, risk templates are really the core enabler of this methodology. They help to remove the need for the security team. And as I've said, they are a collection of 20 threats and their corresponding controls. But each collection, each list, each risk template will be tailored to a specific context. So this could start with something like the implementation. Maybe it's the OWASP Top 10 or a Java-specific coding guideline. It could be compliance, such as FedRAMP for federal government, PCI DSS for payment systems, HIPAA for health. Maybe it's deployment. Maybe your deployment engineer is deploying it on a mobile chip in a phone. Maybe it's deployed on AWS in the cloud. But it's also really important to know that it could be tailored to your organizational priorities. Your security team may have noticed a collection of vulnerabilities that come up time and time again. You could create a risk template from these common themes and use that as well. So essentially, risk templates act as a checklist for developers to identify the most important threats for a given context. Each template also comes with a description of what each threat is, just so the developers can understand it more, and a default risk rating that could range from low to high, and depending on the impact of the threat. It's also great, it's possible to apply multiple of these templates to one model. Say you have a Java web application hosted on AWS that moves money around, so under PCI DSS compliance. There'd be 3 stakeholders there, and each stakeholder could use an individual risk template to get threats relevant to them. And this has the added benefit that each of these stakeholders would become an expert in their domain, knowing what threats would affect them. So this is a quick example of 3 different risk templates. You can see we've got at the top secure coding implementation, AWS, and PCI DSS risk templates. As I've mentioned, you've got the threats, the descriptions, the risk rating, and the suggested controls. At this stage, it's also worth noting that each threat has multiple suggested controls. So you've got 3 controls for each threat, as obviously there's more than one way of fixing things. These are just cut down so they fit on one slide. There will be a slide at the end with a QR code to a GitHub repository where we have a full methodology write-up and the full templates that you'll be able to see in a bit. So let's take a look at the phases of this methodology and how they maybe differ a little bit to traditional threat modeling. We start in the same way by creating a graphical representation of the system, essentially mapping the components, the way the data flows, and how they interact with each other. Next, we move on to highlighting the trust boundaries again, so the way in which that level of data flows from the system to from a user to a system, or so on. But then this is where it changes. We take our risk template and we can use the risk template to identify the relevant risks for each of the components. And then following that, we can map the controls from the risk template as well for each of those risks to the component. And this really helps developers as it makes it much more easy. And finally, we can assess the severity and the residual risk. Maybe the risk is already mitigated. Maybe actually the risk isn't that big of a deal. It's not really a vulnerability and we can ignore it. Or maybe it needs to be mitigated and can be marked for review. So let's take a quick look at an example of how this methodology would work in practice. So here you can see we have a graphical representation of a system on the right and the ticket that the developer was probably provided with to make the system. So we've got the inputs and the outputs of the system and what we expect. We've got the feature use case of the system, so how the system should work. And all of this data would be something that can usually be found on a Jira ticket and would be easily accessible to the developer and they wouldn't have to do much thinking. From this, we can create the following diagram where we've got an application load balancer, the Java web app, the fund transfer service, and the SQL database. So this model is for that Java web app that has that money movement functionality on AWS. And once the developer's drawn that, we can move on to identifying the trust boundaries. So you can see here the developer has the DMC, the private VPC, and the database VPC. They're the three trust boundaries that the developer has control of. And we've got the public network at the top. Next, the developer can move on to identifying threats. So here we're essentially going to act as three different risk owners, or stakeholders, sorry. And you can see that we have the risk templates again for the developer, the cloud engineer, and the risk owner. The developer starts by looking at the top two threats. So the first threat is an IDOR, or a direct object reference, that could allow access to unauthorized data. Well, the developer has decided that this would only really affect the Java app, so the applicable components he puts down as the Java web app. This has a default severity of high due to the data leak that could occur. And the developer also looks at server-side request forgery, essentially tricking the server into sending requests on their behalf. And this could be applied to the application load balancer or the Java web app. Next, the cloud engineer moves on. He looks at an S3 bucket misconfiguration. Well, if we move back to the first slide, there's no S3 buckets there, so he doesn't need to worry, and he can mark the applicable components as none. But the second threat that's on his list is insecure VPC misconfiguration. Obviously, this could allow access to something we don't want people to have access to, such as the database. And therefore, he identifies that all the private VPCs or semi-private VPCs, which have the Java web app, the application fund transfer service, and the SQL database as applicable components. And finally, the risk owner, who obviously wants to make sure we're compliant with PCI DSS, he comes along and makes sure that unauthorized access to cardholder data is not possible. Well, if it was, this would be under the SQL database. And that cardholder data is not retained longer than it should be. Obviously, we have to retain certain data for a legal time period, but after that, we should make sure to delete it. And again, this would be applicable to the SQL database. And then step 4, we move on to those mapping of controls. And at this stage, we can also check if the controls are already implemented, if they're partially implemented, and the developers can provide the rationale behind these controls and their choices. So the application, the Java web engineer, he starts by checking that the access controls are implemented at every level and that randomized or hashed references are used. This limits the IDOR vulnerability, and this is already all done. So he marks the controls implemented as yes and provides his rationale behind that. But for the server-side request forgery, he checks, and the application load balancer, well, that's all good. It's all correctly configured, and he doesn't need to worry. However, the Java web app, well, that sends requests to internal URLs based on a user input. And that user input isn't verified and could be used to craft an attack. So this would have to be raised and marked for review in a further stage. The cloud engineer, he checks the VPCs. They were all done, planned very well, designed very well, and they're all correctly configured. So he can mark that as controls implemented, and he can move on and doesn't have to worry about that threat. And finally, the risk owner, well, he looks at the unauthorized access to cardholder data, and there's already implementation controls in place and logs already enabled. So he doesn't need to worry about that. That meets the requirement for guidance. And then the data retention beyond reasonable requirement, well, cardholder data and user data is deleted as required, but application logs are kept indefinitely. So the controls aren't in place for that. So finally, we can move on to the next steps. Here you can see that for the controls that are already mitigated, we don't need to do anything. So the cloud engineer doesn't need to do anything. The developer only needs to do one of the tasks. And the developer can include his next step. So in this case, it would be to mention it in the next design review. And he can add a risk severity. This is slightly different from the risk rating. The risk rating, we provide him a template. It doesn't change. It will always be the same. The risk severity, if the person doing the threat model has the knowledge, they can amend it so that maybe it's a higher threat, or maybe it's a lower threat, or maybe it's the same. And in this case, for the server-side request forgery, the developer kept the severity at moderate. And the PCI DSS risk owner, well, as I mentioned, only the application data, only the application logs are kept. So actually, we've decided that this is an acceptable risk, and no changes will actually need to be made at all. So finally, we can do that document and reviewing. We can move it all onto one page with the diagram, and we can have all our mapped threats and controls with their risk rating to prioritize them for remediation. So shifting this threat modeling onto the developer allows for many more threat models to be created, and it allows the security team to do something different. The security team no longer needs to be involved in the threat modeling process, but they can be involved in reviewing the threat modeling. So this way you still ensure that the threat models are accurate and correct, but it creates an asynchronous process where the people that are creating the models and the people that are reviewing the models are not the same. And this allows it to be much more scalable in faster or large-paced organizations. And one other thing I would like to go over is, obviously, I have described a very lightweight approach for threat modeling with a scope that is much more easily managed for an individual developer. However, we can make it even faster and even easier for developers. Generative AI has brought a really good opportunity for it. Obviously, it's used for a lot of things, and it's not always great. But for this, we can do model drawing. Essentially, that feature case we saw earlier that could be applied to a Jira ticket, we can provide it to an AI, and an AI can output a threat model for us. And this threat model will also be able to update over time as the system changes. So if your Jira ticket gets a new feature, a new change request, or anything like that, the threat model will update automatically. We can also enumerate threats automatically and apply their corresponding controls. And what this means is we can give the threat models, we can give the risk templates to an AI and apply multiple risk templates to a model automatically. And it means the organization will have the correct risks applied to the components, as well as the firm-wide approved controls. And this really helps with the compliance standard, as you will know what's being applied every time, over and over again. So to actually have scalable threat modeling, we need to start by training our developers on lightweight threat modeling techniques. We need to really move away from monolithic system-wide threat models that don't provide super valuable results. We need to provide the teams with standardized risk templates like lists so that they don't have to think too hard about the threats and get that guidance from the security team. We need to make sure that the development teams are also maintaining the threat models while the security teams are responsible for their review. And we need to integrate tools and help for the developers so that they can generate threat models without the really intensive overhead. So as I mentioned earlier, I'll leave this slide up for a second. This is the link to the GitHub page where you can find all the methodology, all written up, as well as the risk templates in full. So on here, we have the 3 example risk templates that you've seen, but with all 20 threats, all their controls, and everything else. If you would like to try this, we would highly recommend trying with a nice friendly team to start with, maybe not the people sat in a dark corner still using Emacs. And if you would like to, we would also very happily accept any pull requests, whether that be slight changes to the methodology or maybe adding risk templates. We would very happily accept any further risk templates. Now, that was a little bit fast, unfortunately, but does anyone have any questions? Go on.
So you've done this in the real world with development teams, and how's it worked out?
So we have worked with, I think, 14 different companies now, 14 quite large, really big companies that have all adopted this methodology. They've all seen quite positive results, and most of them, I believe, have completely moved away from their traditional monolithic threat modeling. So it has been effective, and it really helps to catch those securities vulnerabilities much earlier due to that.
I'm sensing a trade-off between the things that will be blind spots by narrowing down the focus, by not doing something holistic, and the extra value that we're hoping we're going to achieve by having extra relevance to the folks we're working with. Are they acting on that extra relevance?
Yeah, so I assume as well in that case then you also mean that maybe it might still be worth doing normal threat modeling. And some of the companies we worked with have done that, so some of the companies have kept the traditional threat modeling and adopted this methodology to make sure that that extra relevance is actioned upon and that the development teams that are responsible for the individual threat models can action those results. But the leadership team, the senior team, will still have that overall threat model where they can still get the results they want to see as well.
It's both.
Yeah.
Thank you so much.
I have a question.
I was going to go to the guy in the back first.
Let's say I have a team of 5 devs.
Yep.
How do I, and they're building something, how do I know that I'm getting the right risk levels? Because you don't have an identification of what they're actually building.
Okay. But they will know, so if they would probably know if they need the OWASP top 10, you could provide them with the OWASP top 10.
I have BIOSes, I scale across everything. So I don't know what they're doing. So how can I understand that without understanding what the structure looks like? And even the devs don't understand the structure. And I've seen that time and time again. How do you take what you're saying? How do I know which templates need to apply to this team without understanding what they're building?
So are you part of the security team for your company? Or? Yeah, so obviously the security team will know what vulnerabilities have come up in the past, and maybe it would make it harder to start a threat model for a brand new system. But if you've got issues in a current system or anything like that, your security team would be able to work with the developers to create a risk template that's applicable for them in their use case.
The devs half the time don't know what they're building. You're missing the diagram part. In my frontline experience in recent years, I've seen more value in having the devs just doing the diagramming so they get on the same page than any of the security. And if you miss that spot, you're toast. And you can do this in a lightweight because it is a small subsystem
Yep.
for building.
Yeah.
And it's very quick and easy to do, but you really need to incorporate that. And if you do, then you can actually apply your templates.
Yeah, that's a really good point. But I don't have a great answer for you right now.
Try that. Really just write lightweight diagram. I say, even if it's on a piece of paper.
Yeah.
Or napkin, it works well.
And last question.
Yeah. So while determining the risk of the threat, like what factors should we consider?
What's that, sorry?
While determining the risk of the threat.
Okay, so how do you determine the risk?
The risk, yeah.
s-
What factors should we consider?
So that's why the severity is quite optional, and really it only needs to be applied if the developer has the understanding. You could use the default risk rating that the template provides, using the description and making sure that it matches. But if the developer doesn't have the knowledge, they can just stick with the default one. If they do have the knowledge, they could try and decide themselves what level of severity it is.
Again, does it depend on what is the data behind, like whether it is a PHI, PA, like
Well,
what factors does it?
it would depend on what it would depend, like if the developer doesn't know the factors behind it, well, he can't pick the risk, and he would choose to ignore that stage. But I think maybe we can talk a bit after this, and I'll try and understand your question a bit better. Cool. Thank you very much, guys.